Good day, ma'am. Good day, everyone. I am Fiancé Arbanio, together with my groupmates, Mr. Ralph Casas and Miss Aprilian Miao. Today, we will be presenting about experiential and situated learning theories and how this can be applied in the teaching of mathematics. At the end of this lesson, you should be able to: first, compare and contrast the concept of experiential and situated learning. Second, identify practical examples of both theories in teaching mathematics. And lastly, demonstrate understanding of how each theory supports authentic and applied learning. Before we begin, I know that you already have an idea about this, but let's gonna dig deeper about this topic. Let me first give you a brief introduction that both experiential and situated learning focus on learning through real experiences. Instead of just memorizing lessons, students actually do activities, reflect on what they've learned, and apply it in real situations. In math, these approaches make learning more meaningful because students can see how mathematical concepts work in real life. So what is experiential learning? From the word experience means to provide experience with direct observation of something. So this theory was introduced by Dave Cobb in 1984, inspired by other theorists such as John Dewey, Kurt Lewin, and Jean Piaget, where their ideas of John Dewey learning by doing, Kurt Lewin's model of change, and Jean Piaget's cognitisms in one. So Cobb defines experiential learning as the process where knowledge is created through the transformation of experience. In simple terms, we learn best when we directly experience something, reflect on it, and then apply what we learned in new situations. Cobb explained that learning is a continuous cycle with 4 stages. First, we have the concrete experience, where learners actually do something such as performing an activity. Second is the reflective observation, where student or learner can think about what happened and what they learned. Third is the abstract conceptualization, where student or learner can form new ideas or understand the concept behind the experience. And fourth is the active experimentation, where students or learner apply their new knowledge in another task. And it is a cycle that can be back again and again. So, this cycle shows that learning doesn't stop at one point. It's a process of doing, reflecting, thinking, and applying. For example, in math, where concrete experience takes place. For example, the learner currently measuring objects, where students learning by doing at the moment, such as the student are measuring shapes, lengths, or areas. So this gives them direct hands-on mathematical experience. Then up to diverging, where a learner is exploring different ideas and visualizing the concept. After that, the learner thinks and observes. Then the learner is in the second stage of Cobb's theory, which is the reflective observation, such as analyzing the problems. So after that activity, students reflect on what they did and observe, analyzing measurements, identifying patterns, or even discussing results. Then up to assimilating or assimilation, wherein learner focusing on analysis and logical understanding. Then the learner will proceed to the third learning stage of Cobb's learning style, which is the abstract conceptualization, such as learning formulas. So from that reflection, students from ideas or concepts, they connect their experience to the math principles, such as formulas for area, perimeter, or volume. In this area, students manipulate and conceptualize of what he or she reflect. Then up to converging, where learner applying math concepts to solve the problems. Then he or she proceeds to the fourth stage of active experimentation, such as, for example, building models, where students apply what they learned by creating models, solving new problems, or experimenting with the formulas in different contexts. Then up to accommodation or accommodating, where learner learn through hands-on experience and creation. The learner on this integrate his or her idea in the context of another until he or she found out another concrete experience, then the concept cycle again and again. So overall, it shows that in math, learning becomes more meaningful when students experience, reflect, conceptualize, and apply mathematical ideas in practical ways. So let me give you some examples in the field of math wherein the individual process of a learner may be situated. For example, in geometry, students can measure the school garden to calculate its area and perimeter and then design an improved layout. So through this, they experience math directly by observing, measuring, and applying formulas to solve in a real-world problem. This activity helps them understand geometry concepts more meaningfully than through lectures alone. Another example is in algebra. So students can collect data like the heights of their classmates and use it to create a linear equation that predicts growth patterns. Here, they see how algebra is used in real life to describe relationships between quantities. So they are not just solving equations, they're connecting math with real situations. Third example is in statistics. So students can conduct a survey about their favorite snacks in class, then compute for mean, median, and mode, and present their findings using charts. In this way, math becomes more than just numbers. It turns into a tool for understanding data and making informed conclusions. Remember, whether it is an individual or collaboration, experiential learning can be happened anytime.
So let us proceed to another topic, which is situated learning theory. Situated means placed in a real context or it is embedded in the actual situation where the knowledge is used. So, ang pagkat-on, mahitabo kung ang lesson kay na-acute sa tinod nga situation or real context. Meaning, ang knowledge, dili lang gina-teach sa classroom nga walay connection sa reality, kundi gigamit yun sa actual nga situation kung asa siya applicable. So, dapat nga ang mga students maka-learn through sa mga experiences nga related sa real world. Pananglitan, kung nag-study ka about business, so mas maayo nga makatry ka unsaon pag-plan o pag-manage sa imong business para masabtan nimo unsa gyud ang real process. Mauna ang masabot sa situated learning nga ang pagkat-on dapat naka-embed o na-play sa tinuod nga context aron ang knowledge mahimong useful o meaningful. Situated learning. Situated learning was proposed by Jean Lave and Etienne Winger as a model of learning in a contextual environment. According to Jean Lave, mathematical skills learned in different contexts reveal that each of these groups found ways of solving mathematical problems without using the general math techniques taught in school. So, tinuod no nga ang learning mas faster o clear kung naata sa real situations. So, sa pong ni Jean Lave, ang mga tao nga nag-use of math in different contexts sama sa mga works like marketing, construction, also kining na sa DPWH and accountant, etc. Nagamit sila og problem bisan dili gamit ang mga technique nga ginatudlo sa school. So mas maayo gyud nga ang mga students makat-on through experience og sa real life situation kay diha nila masabtan unsaon paggamit sa ilang knowledge in real life. Dili lang sa sulod sa classroom. Okay, so there are three concepts of situated learning theory. So the first one is the authentic context. Learning occurs through real-world and meaningful tasks that reflect how knowledge is used outside the classroom. It connects lessons to genuine experiences, making learning more relevant and practical. So, sa situated learning, when we talk about authentic context, it means ang learning dapat mahitabo in a real-world setting. Dili lang kay sa classroom lang utob, kundi ma-apply yun in real life. So, dapat nga ang mga activities nga ihatag sa teacher kay connected sa mga experiences nga pwede nato ma-use outside the classroom. Aron ang mga students kay makasabot unsaon paggamit sa ilang knowledge sa real situations o dili lang kay memorize lang. No? So the next one is the social interaction. Knowledge is constructed through collaboration and communication with others. Learners engage in group discussions, peer teaching, or mentorship within a community of practice, where they learn from shared experiences. Dinhi ang learning happens when students work and communicate with others. Dili lang mag-study nga independent, kay mas dali man gyud masabtan ang lesson kung magtinabangay o mag-share sa mga ideas. Through group discussions or teamwork, maka-learn ta unsaon pagpaminaw sa uban, pag-share sa mga opinion o pag-cooperate para ma-create og maayong result. Pananglitan, kung naamoy group project, diha nato makita nga ang learning mas epektibo kung magtinabangay. Mao nang dinhi sa social interaction, ang knowledge mas lig-on kung gi-share o gitrabahuan sa uban. Okay, the third one is the constructivist learning approach. Students build their own understanding through experience and reflection rather than just receiving information. The teacher acts as a facilitator, guiding learners to construct meaning from authentic activities and interactions. It means the student should not just listen and receive the information gikan sa teacher, kundi sila mismo ang mag-build sa ilang own understanding through experience and reflection. Maka-learn sila sa ilang kaugalingon nga paagi. Ang teacher, dili na murag lecturer lang, kundi usa ka facilitator nga nag-guide sa students para sila mismo makasabot unsay meaning sa ilang gibukat. Pananglitan, kung mag-activity nga based sa real-life situations, ang student mo try, mo observe, o mo reflect sa result para makuha nila ang tinuod nga lesson. So, in this approach, learning becomes more meaningful kay ang knowledge ilan ang na-discover o na-experience mismo, dili lang gisulti sa teacher. Okay, the next is the example number 1, the community budgeting. Okay, students help plan a class or school event budget applying concepts of percentages, ratios, and expenses. So for example, sa number 1, which is community budgeting. Ang mga students mutabang sa pag-plan sa budget para sa class or school event. So in this activity, they apply what they learned in math, like percentages, ratios, and expenses. Dili lang ni paper and pencil work, kay gamit gini sa real life. Through this, maka-learn sila unsaon pag-manage sa kwarta, pag-plan sa gastuhon o pag-decide kung asa dapat gamito ng budget. Mo na siya ang example nga ang learning kay mas meaningful kung magamit sa tinuod nga situation, dili lang sa sulod sa classroom. Okay, so the next example is all about the market simulations. Okay, students simulate buying and selling goods using profit, loss, and discount formulas. So, for example number 2, which is market simulation, ang mga students magbuhat og activity nga murag naa sa market, nag-buy and sell goods, no? In these tasks, they use what they learned about profit, loss, and discount formulas. Dili lang sila nag-compute sa papel, pero kina-practice nila unsa ang pagkwenta kung pila ang tubo or lugi. Through this, makasabot unsaon paggamit sa math sa real life situations like business or selling. So it's a fun and practical way of learning. Okay, the last example is the architecture or design tasks. So students observe local buildings and identify symmetry, angles, and proportions. In this activity, they identify symmetry, angles, and proportions that they see in real buildings, right? So through this, students can understand how mathematical concepts are actually used in architecture and design. Dili lang sila magtanaw sa mga books or mag-drawing. So, makita gyud nila in actual kung unsay shape sa building, kung asa makita ang symmetry o angles. This helps them realize that math is not just numbers and paper but something used in real life to create balance and beauty in designs. Ang learning kay connected sa real world situation, which makes it more meaningful and practical. That's it.
The continuation of our topic. How both theories are related. Situational or situated learning is a specific type of experimental learning that places a strong emphasis on learning within the original context of application. Situated learning specifies this transformation should occur within an authentic, social, and real-world environment. Is focus, role of a teacher, and lastly is environment. In the experiential learning, learning through personal experience. Situated learning is learning through social and real-world context. Role of a teacher, the experiential learning is facilitator of reflection. Situated learning is facilitator of collaboration and community. Lastly is environment. In the experiential learning can happen in any experience, which in the situated learning must occur in authentic context. In conclusion, experiential and situated learning both emphasize that meaningful learning occurs when students are actively engaged in real or realistic experience. Rather than passively receiving information, experiential learning focuses on the learner's personal cycle of knowing, reflecting, conceptualizing, and applying, while situated learning highlights the importance of learning within authentic context and through social interaction. Together, these theories show that effective education is not confined to memorizing facts, but involves connecting knowledge to life situations and communities. When applied to mathematics teaching, they encourage learners to explore, collaborate, and apply mathematical concepts in practical ways, transforming abstract ideas into understanding grounded in experience and context. That's all. Thank you.